Okay. So we yesterday looked at some graphs again, determining those equations, and then we started looking at using a table to determine equations. And we wrote down a method, okay, where we said calculate a gradient using any 2 points and sub in to find any 2 points. And then we did one together, and then I told you to choose any points by yourself, and we took Amy's points. So today we are going to start off with this example. So right now, I want us to determine an equation, and my question to you would be, if I can choose any 2 points to calculate the gradient, would I choose
8mt, please report to H30 now, 8mt to H30.
Would I choose those 2 that have information missing? No. Okay, so just choose information that you can use to determine that equation. Are we still busy? Okay, giving you a moment. Okay, having a look, choosing any point. So if you are smart, you will avoid the fraction. Okay, since we can choose any points. So y equals to mx plus c is my goal. I can calculate m by choosing two coordinates, minusing the y's and then minusing the x's. Okay, I'm going to choose minus 2 and 2. So 5 with its partner minus 2 and 3 with its partner 2. So I will then have 2 over minus 4, simplifying to negative 1/2. Anyone not get negative 1/2? It's not your mistake, it might be a mistake in the question. I remember last year there being a mistake. Anyone not get negative 1/2? Okay, so now I can update my equation. Negative 1/2 x plus c. I can choose any coordinate to replace it. I'm going to avoid the fraction and I'm going to say 0 and 4. 0 for x, 4 for y. So I would have 4 in my y, x is 0, a half times 0 is 0, so c is just equal to 4. Therefore, my equation equals negative half x plus 4. Any questions? Amy, what's wrong? Plus 2. What did you substitute? Did you get the negative half? Yes. And what did you substitute? 2 over 3. So 3 for y equals a half times 2. A half times 2 would be negative 1. Negative 1 going over becomes 4 plus 1. 3 plus 1. You minus. Okay, anything else? Thank you for that correction. Anything else? Easy peasy. Now, what am I going to expect you to do with that W and that V? I'm just going to substitute. Okay, so I'm going to do it next to. So I have my equation now, right? Whatever your equation was is what you would use. I want to find W. W is the x value, so now I'm going to replace x with W. Y is equal to 2. So I'm just going to solve for W. I'm going to give you 1 minute to solve for W. Okay, so we have plus 4 going over, becoming minus 4. So I have minus 2 equals to negative a half times W. You can either divide both sides by the half if you have a calculator. Else, I want to get rid of a negative, so I times by negative. And I want to get rid of a division by 2, so I times by 2 on both sides. So I have negative times negative is positive, and 2 times 2 is 4. So W is equal to 4. Now let's do V. I still have my equation of y equals to negative half x plus 4. 10 is my x. V is my y, so I'm just solving for V, giving you 30 seconds to do that. So we have a negative a half times 10 equals 5 plus 4. V is equal to negative 1. Yes, Logan.
Oh, ma'am, yesterday I got, yesterday I got number 2 wrong, but I don't know what I did wrong.
Do you mind if I come look?
Yeah.
Yes, you mind.
Yeah, I mean, no, I don't mind. Minus 2, minus 5, minus 2, minus 1, and then minus 1, minus 12, minus 2, plus 1, minus 1, obviously 12. And then I substitute the 1 to the negative 1 here. Okay, so negative 1, 12 times 1, minus 1. Oh, because you would have taken, if you took that over, it would become minus C. And to the plus 1. So technically, there's minus 12, minus 1, minus 12. So it would be minus 13. Okay. What are you doing? I don't know. No, I mean, like, where did the example come from? It's from yesterday.
I don't remember that, but okay.
I think it was from yesterday.
Any questions? Can we start on parallel lines? Do we need to do another table 1? Okay, parallel lines. New color, new day, I think. The new day, new color. Oh, blue is missing. I wonder if we'd see orange, which would be too light. Let's check. Okay. Go to Tuesday. I want group 1's notes so that we can have exactly the same notes. Okay, so we haven't written anything about parallel lines yet. Okay. Feels like we have, but anyway. Parallel lines, gradient 1 equals to gradient 2. I shouldn't have told you that, but okay. So 9OL, we already have written that on the previous page. We are busy with parallel lines. Can you see the orange? Nice and clearly. Okay, parallel lines. Anyone remember what a parallel set of lines are? Eden? They will never meet. Anything else that you can say about them, Amy? They're next to each other. But I mean, this and this can be next to each other. Doesn't mean that they're parallel, Amy. They don't have to be the same length, no, Logan. There we go. So that's what I'm looking for. Yes, they are next to each other, but at every point on those two lines, they are an equidistant distance apart. So equal distance at every point. So firstly, we're going to write there 2 or more lines which are equidistant. That's just fancy for saying equal distance from each other. Equi meaning equal, distant meaning distant. 2 more lines equidistant from each other at every point. Now, if I wanted to take a line and put it on a Cartesian plane, so let's draw ourselves a Cartesian plane, and I found my ruler somewhere. Oh man, somewhere in there. Okay, so drawing, I'm leaving a little bit of space for a note, and then I'm drawing, only need 2 lines, and then I'm drawing my Cartesian plane. My y-axis is still my y-axis, my x-axis is still my x-axis. Okay, and now I'm going to draw a random line. Okay, random line. Now I need to draw a line that is parallel to that line. So we know that it's going to be 2 more lines that are equidistant from each other at every point. So would you agree with me that the 2 sides of my ruler are technically parallel because they are equidistant at every point? So I'm going to use my ruler as a quick trick just to draw another line that's parallel on my axes. Oh, if I could actually keep it straight. Okay. Hopefully your line is neater than my line. Okay, so at every point I use the fact that my ruler was a straight ruler without curves and chunks missing, and I drew another line that was parallel. Okay, now what can you say about these 2 lines? Do they have the same y-intercept? What is the same in these 2 lines? No, there's my x-intercept for the orange and my x-intercept for the blue. So can I say that the slope is the same? Okay, it hasn't gone any steeper or any flatter. So my slope is the same. But what determines a slope in a straight line? The gradient. So what can I therefore say about 2 parallel lines? The gradients will be the same. So my first note is that parallel lines have the same slope, and therefore they have the same gradient. Therefore, same gradient. Parallel lines have the same slope, SLOP, therefore the same gradient. So since they are parallel lines, I will always know that the gradient of my first line will equal the gradient of my second line. But we also need some kind of indication. We can't just assume because it looks parallel that it is parallel. So there are 2 ways that this can be given to you. That is either by giving you arrowheads on those lines. Arrowheads tell me that these lines are parallel. Okay, so arrowheads, parallel lines, therefore gradients equal. The other way is I can actually tell you that equation 1 is parallel to equation 2. So it's either by the arrowheads or in words that I tell you that they are parallel. And only once I tell you that it is parallel that you can use gradient 1 equals to gradient 2. So parallel lines can be given as arrowheads or in words. So writing parallel, I'll probably always use the two lines. It's easier, quicker. So parallel lines can be given to you as arrowheads or in words. Okay, so let's do an example together. Can I take this page off? Okay, determining our first equation that uses parallel lines. So example, determine the equation of the line parallel to y equals to 2x plus 3 and going through the point minus 1 and, positive 1 and minus 4. So determine the equation of the line parallel to y equals 2x plus 3 and going through the points positive 1 and minus 4. So the equation of my first line is y equals to 2x plus 3. And we get told we are looking for a second line, a second straight line. So my starting point of my new line, since it's a straight line, would be y equals to mx plus c. And we get told that this new line is parallel. So we already get told what my gradient is, because it'll be exactly the same gradient as the first line. So what is the gradient of my new line? It is also 2. So just for this example, I'm going to write that down. Okay? M1 equals to M2. Gradients are the same. I would not need to write this down when I was calculating. It's just for demonstration purposes. So therefore, I can update my new line as 2x plus c. So there's my gradient. So I use my gradient in the new line. But I need to get a full equation, which means my c value still needs to be solved. What information can I use to solve for that c value? I don't have the intercept yet, no. The coordinate given. I gave you a coordinate, so I just have to sub. Minus 4 for y, positive 1 for x. 2 times 1 is 2. Just showing you every step, but you don't actually need to. So taking that positive 2 over, c would be equal to minus 6. Therefore, since I wanted the equation, my new equation is 2x minus 6. Let's try another one together. Actually, you're going to do it yourself. So exercise. Determine the equation of the line. I'm lazy. 2. Parallel to y equals negative 2x minus 2, and going through, I'll show it to you in a second, 0 and 8. So exercise, so you're doing it by yourself. Determine the equation of the line parallel to y equals to negative 2x minus 2, and going through the points 0 for x, 8 for y. Okay, you should be done. That was my original line. What is my goal? My goal is y equals to mx plus c. What is my new gradient of the new line? Negative 2x plus c. What am I going to do with that 0, 8 coordinate? Minus 2 times 0 is just 0, so c is equal to 8. Therefore, my equation is y equals negative 2x plus 8. Okay, if I had to give it to you in that form, would you be fine? Okay, let's look at it if I had to give it to you on a graph, not in word form. Okay, can I take this off the board? Nicholas, okay. So we'll first do an exercise and then we'll do an example. No, the other way around. First example and then an exercise. So my example is, I give you a Cartesian plane. X-axis, Y-axis. So I get two lines. F has got -4 and 3 on those axes, and G has got -2 on that axis. And the
the reason why I've now introduced names to those lines is so that I know which line I'm referring to when. Instead of new line and old line, I'm now calling it F and G. And my equation would be the same. Determine the equation of F and determine the equation of G. So looking at F and G, which one is the easier one to solve first? Why, because I get more information. I get 2 points, which means I can do a gradient, which means I can sub to find the letter C. But now, remember that this, I tell you that minus 4 on the x, which means it's got a coordinate of minus 4 and 0. 0 on my x-axis, which means y is 0. This is cutting my y-axis, so x has a value of 0 for x, y has got the 3. So that's what I'm going to do first. I'm going to fill in those coordinates because I need to use the coordinates to find the gradient. So since it cuts the x at minus 4, the x is minus 4. Therefore, the 0 goes to y. It is cutting my y-axis, therefore the 3 goes to y, and the 0 is my x. And while we're at it, we may as well do this one as well. Minus 2 for the y, but 0 for the x. Okay, so my first step is trying to find f. Now, f I know is a straight line, so it will have y equals to mx plus c. I can find my gradient by calculating y2 minus y1 over x2 minus x1. The 2 points that I'll use is minus 4 and 0 and 3. So I'm going to have 0 and minus 4. And then the y is 3 minus 0. So I would have negative 3 over negative 4, which is positive 3 over 4. I'm just going to write next to it. So my gradient is positive 3 over 4, so I can update y equals to positive 3 over 4x plus c. Now I just need to substitute in a point. Which point is going to make my life easier? Negative 4 and 0 or 0 and 3? 0 and 3. So 3 for y. Timesing by that 0 means this whole term becomes 0. So c is equal to 3. Therefore, y equals the 3/4 for the gradient plus 3. So that would be my calculation to find f. I would still need to go and find g. G is also a straight line, so I also want y equals to mx plus c. And I'm going to follow the same things. I want to solve for m, and then I want to solve for c. Do I have enough information to do the gradient calculation for g? But what do I know about f and g? How do I know they're parallel? The arrowhead. So if they are parallel, what are we knowing about their gradients? They are the same. Therefore, I can update immediately. And now what?
I've got my M. I still need my C. Substitute that point that's given to me. What point? 0 and minus 2. It has to exist on that graph. Okay? So 0 for x, minus 2 for y. That's just going to become 0. So C is equal to minus 2. Therefore, y equals to 3 over 4x minus 2 is my answer for G. How many units did the graph shift to go from F to G? So remember, they're equidistant at every point, right? So if I can find two coordinates, for instance, like this y-intercept and that y-intercept, I can actually see the shift. Because I went from positive 3 in the x, in the y, to negative 2 in the y. So I had to shift 1, 2, 3 units to get to 0, and then another 2 units to get to minus 2. So how many units did I shift in total? 5 units. So for this x value, which is minus 4, this x value will also be minus 4, but what will the y value be? If I shift from 0 to 5 units, it would be minus 5. And I could actually do that at every point, x point on my axis. They will be 5 units apart in the y. The x will be the same, but the y's will be 5 units apart. Okay, I'm going to give you one to do by yourself. Just want to find one that I know works. Or someone's still busy. Okay, exercise. Okay. So my question is, determine the equations of f and g.
Motion please for some break announcement. Mrs. Mann's grade 11. Mrs. Mann's grade 11 maths class must go to lecture room 2, period 5. Downstairs B wing and C wing may be dismissed now for break.
Okay, I want you to do that for tomorrow. If you haven't finished already, we'll mark it as soon as we get in. You're going to ask any questions if you have them. Maybe we'll do one more, and then we're going to look at perpendicular lines. That's on Thursday, obviously not tomorrow. Okay, so let's pack up, please.
Hayward Centre, upstairs C wing and A wing may have been enough.